So you've talked about parameters. What do you mean when you talk about parameters?
So when I think of parameters, in terms of your experiment or your unit operation, you've inevitably got kind of three levels of parameter. You've got your input parameters, you've got your kind of output parameters, and you've got your raw material parameters. What we're really talking about here is your input parameters. What parameters are you going to control in order to maximize and control your manufacturing process? And these would be things like your critical to quality attributes or your critical process parameters, for example. When we're talking about critical process parameters across the context of process development, what we're really talking about is how do we go from knowing very little about our process and our parameters to fully determining whether they are critical as part of our process towards our critical quality attributes, and what are the specifications that we need to control in order to ensure that we're making a safe and effective drug.
How do the needs around kind of understanding and tracking these process parameters impact the process development into manufacturing tech transfer space?
I think at the moment, tech transfer tends to come later in the journey. So it's, there will be tech transfers at all the different phases, from phase 1 to phase 2, phase 3, as you maybe go between different laboratories or different sites as you're performing different execution. But when we talk of tech transfer, what we're kind of really talking about is this position where we move from a development into manufacturing, which is normally kind of around that phase 3. At this point, we perform process characterization and we try and characterize the process as much as we can so that we know what we're doing to hand into manufacturing. This is a big chunk of work, and traditionally, it can take kind of 15 to kind of 20 months. And at that point, we have what we say the parameter is kind of set in stone and we've handed it off. Now, what happens in manufacturing is they will then take those parameters and construct their process description, which goes into their manufacturing execution systems. And they take it as version 1 and we're going to run with it. If something goes wrong in manufacturing and we get a deviation or something like that, one of the things that's really useful is to be able to go back and discover why and when was that parameter classified and what was its specification and what were the experiments that went into it. And at the moment, we only have this kind of stop piece history in time of this is the specification as we move forwards. What we're kind of suggesting is actually, wouldn't it be great if we had the history of that specification and how that specification evolved to be what it was?
Why is the management of these processes so important and critical for drug development?
So the process that you define and you design as part of process development is ultimately what you manufacture. And when we are manufacturing, we are looking at these parameters and we are ensuring that if we keep them in control, we are confident that we will produce a safe and effective drug that we can sell to the market. So by controlling the process, you control the quality to an extent. So as long as you know what your process is and that you are in control of your process, you have an expectation that you're going to make a manufacturable drug. So when we look at process development, why is it really important that we make and control these processes to a really good high level and a good degree to quality? Because if we make this mistake in process development, if we get our specifications wrong and we don't control our process correctly, then that will pass on to manufacturing and that will lead to failed batches and it will lead to loss of revenue.